So we're going to start an educator hat just for a moment while I tell you a little bit about the unit and where it belongs in our scope and sequence. So Open Science High School is 3 courses, as Sarah told us: biology, chemistry, and then physics. And each of these 3 full-year courses also incorporates earth and space science, as well as the engineering design core ideas. Each course has 5 to 6 units and has its own bundle of performance expectations that are shown here. So what this is a map of is all the performance expectations for high school, every single one of them, and where they fall in our scope and sequence. So we're looking today at the physics and earth and space course, which is the 3rd column in this map. And we're looking at the first unit, which is that top right rectangular bubble in the top right. You'll notice that there's color coding for the performance expectations. So that shows if it's a life science, which is in green. You'll notice there's no life science in physics. If it's physical science, then it's in red. If it's earth and space science, then it's in blue. And if it's an engineering performance expectation, then it's in black. So you'll notice that there are no units that are just one color except for P5. But other than that, all the units are really a mixture of these different performance expectations. So taking a closer look at the performance expectations for this unit, which is the first unit in the physics course, that's the 3rd course of the sequence. There are a lot of performance expectations in here, so I'm going to go through them in 2 different slides. The first 4 are all physical science performance expectations. You'll notice that a lot of these have asterisks and daggers. Those indicate that this is not the only place in either the unit. If it's an asterisk, it's not the only place in the course where that performance expectation is covered. So we may not get to all of it, but if taken together with the other place where it is covered, we are covering the entire performance expectation. So that's what the asterisk means. The dagger means that it is covered over different courses. So if there's a dagger, that means that this may have been developed in an earlier course, such as biology or chemistry. So the first one is about electric current and magnetic fields. We've got 2 performance expectations about the interaction between electric and magnetic fields. We've got a performance expectation about energy. We have a lot of performance expectations in this unit about energy. It's a very energy-focused unit. And then this last one, design, build, and refine a device that works within given constraints to convert one form of energy into another form of energy, is kind of borderline between, it brings us into our engineering focus. And it is only covered in this unit. So if you go to the next slide. This unit also hits on some performance expectations around creating computational models for energy. Modeling energy is a huge focus of this unit. And then evaluate a solution to a complex real-world problem. So these next 2 performance expectations are engineering performance expectations. And that manifests in this unit as students thinking about, it's less about the way we traditionally think of engineering as refining a device right here in front of me in the classroom, and more about thinking about large-scale solutions for the problem of our electricity grid. And how we're going to create a grid that aligns with our community values and is going to help provide reliable electricity for our community, whether that's a local community, a cultural community, or a global community. And then finally, we've got an earth and space science performance expectation. Evaluate computing design solutions for developing, managing, and utilizing energy and mineral resources based on cost-benefit ratios. And this is shared with chemistry. Chemistry also has a unit that's very focused on this performance expectation, but we look at it in kind of a more physics perspective. So we are intentionally developing certain science and engineering practices in this unit. And because this is the first unit in the physics course, we're really focusing on providing a foundation for these practices over the rest of the course. When we say intentionally developed, that means something very specific for Open Science. That doesn't mean they're the only practices that are being used. We also have practices that are key to the sense making. But being intentionally developed means that we are scaffolding those practices or those cross-cutting concepts. They are being used maybe in a new context, or there is a new element of that practice or cross-cutting concept that has not yet been developed. So the intentionally developed science and engineering practices for this unit are asking questions and defining problems, developing and using models, analyzing and interpreting data, and constructing explanations and designing solutions, specifically here. And for the cross-cutting concepts, we really focus on systems and system models. We're modeling energy flow through systems. And then we're also, and we develop a framework for thinking about the relationship between energy and matter. I'll talk about this I think I'm going to talk about this a little bit later, but if not throughout this course, we're going to be developing a theoretical framework for thinking of, or a conceptual framework for thinking about energy, matter, and forces and how those three things interact. And in this unit, we're setting the foundation for that triangle, which we call the energy, matter, forces triangle, by really thinking about the relationship between energy and matter. And we will layer in forces in the next unit. And then for the rest of the course, we think really deeply always about which lens should we be looking through and how are these three things interacting. And then finally, this unit really focuses on stability and change. We're thinking about when are our electricity systems stable and when do they change? And we have to be thinking about stability and change, it turns out, on multiple different scales in order to answer that question, whether it goes down to the scale of electrons in a wire all the way out to the global scale.